So here we're looking at a question from a previous JEE Mains question paper, and I believe it's from September 2021. And online it's question number 10, question paper shift 2, I guess it's called. Not exactly sure about that, but let's get to solving this. So it says an engine is attached to a wagon through a shock absorber of length 1.5 meters. The system with a total mass of 40,000 kilograms is moving with a speed of 72 kilometers per hour when the brakes are applied to bring it to rest. In the process of the system being brought to rest, the spring of the shock absorber gets compressed by 1.0 meters. If 90% of the energy of the wagon is lost due to friction, the spring constant is blank multiplied by 10 to the power of 5 newtons per meter. All right, so I'm going to work with my given here, so I know that my mass of my system is basically equal to 40,000 kilograms. I know that my initial speed, initial speed, 72 kilometers per hour. Even if we can turn our 72 kilometers per hour into just 20 meters per second. Now we're going to look at the compression of the spring. The spring is compressed by 1 meter. So, because we're going to be using the spring formula where we know that compression is 1.0 meters. Okay, and it says here that 90% of energy of the wagon is lost. So 90% of energy is lost. I'm just going to state it here, 90% of energy is lost. All right, so now let's get to solving it. So firstly, I can state this, right? I know that my kinetic energy is equal to half mv squared, right? And I can sub in my value. I know my mass. So my kinetic energy equal to half times my mass of 40,000 times my velocity squared, which is 20 meters per second squared. So 20 meters per second squared. And this gives me an answer of, if we just call it, it would be times 400. So it would be an answer of 8 million joules. Oops. 8 million joules, all right? So that's the, kinetic energy that we have here. Now we know that 90% of the kinetic energy is actually lost to friction, right? So basically we know that the energy lost would be, I can just write it here. My E lost, I'm gonna write E lost, would actually equal 0.9 multiplied by 8 million. And this would give me an answer of 7,200,000. All right. So from there, we can kind of figure out that the remaining energy in the spring should just be 800,000. So I guess we're gonna write E spring is equal to 800,000 joules. All right. Now we can just use the spring constant stuff. Or I meant to say spring constant formula. So we know that E spring is equal to, remember, half times K times the change in X, which is, remember, our compression squared. So it's going to be equal to half. Remember, we can plug in our E spring, which is 800,000, is equal to half K. So it's going to be half K change. And remember, this is what we can just put 1.0. We can sub that in. Put up my values. Okay, now our next step would be to solve this. So this would be calculator here. We'd be isolating for K. K would equal 2 times 800,000. And then you would just be left with K is equal to 1,600,000 newtons per meter. And if we were to simplify this, this would just be 16 times 10 to the power of 5 newtons per meter, because that's the proper way to say it. So we just put 16. So the answer is 16 multiplied by 10 to the power of 5 newtons per meter. And that's it, solving this problem.